Greetings, M Squared here, and today we are going to talk about solving quadratic equations from a graph and a table. We're going to do some little estimating too, but we're focusing mostly on tables, and we're going to do a little bit of the graphs, because graphing was the other video. So, when you look at a table, remember, well, first of all, we want to make sure we remember that solving a quadratic equation means finding the x-intercepts. So let's review that, right? We're going to find our x-intercepts. That is the same thing as the solution. X-intercepts equal the solution. X-intercepts happen on the x-axis, and that all along the x-axis, y is 0. So we're really trying to find when y is 0. What x value happens when y is 0? So if you know those two things, that's going to really help you. So values, when you have a no solution, because remember from before, let's go back to this little guy. Remember from the previous talk that either we get a no solution because the parabola opens up and never touches the x-axis at all, or opens down, or we have one solution where it just touches it and goes back up, or it has two x-intercepts or two solutions. So remember those three things, because now we have the same thing. So this is our no solution, our one solution, and two solutions, but with tables. So what you'll notice is that here's my vertex. I can tell because I have that symmetry, but my vertex never drops below the x-axis. So it goes 11, 5, 2, and then it comes back up. So here's my x-axis, it comes down, and then it comes back up. So there's no solution. It doesn't cross the x-axis. And that can happen at the other side, too, where you have the x-axis here. And notice it goes from -5, -2, -1, and then it just goes back down. So you can tell because they're either all positive with the vertex right there in the middle, or all negative with the vertex right there in the middle. And again, you can see that symmetry. So that's what a table is going to look like when there's no solution. What would a table look like if there's one solution? Well, because we're looking for when y equals 0, we always want to, I just look at the y's and I go, oh, there's a y equals 0. How many are there? Well, that's the actual vertex. So that means it just hit there and went back up. So that's one solution. And then over here you'll see that I have two solutions. I have 2 times where y is 0. So what are my x-intercepts? -3, 0, and 3, 0. So that's how you look at a table and find out what the intercepts are. Alrighty, so let's look at this. It says if the x-intercepts are not integers, these were all pretty integers, right? They may not be listed so that you can't see them. So look right here. Just because there is no 0 for y doesn't mean that I don't have any x-intercepts, because it would be right there. It goes from 5, and then so from 5, 5, then it goes, wait, sorry, we're going up, -5, then it goes 1, 3, and then it goes back down. So somewhere over here, it crosses the x-axis because it goes from negative to positive. So where you see this negative to positive happening, we know there's an x-intercept right there. Well, we just don't know what it is. But we know that it's probably closer to this one. So it's probably closer to 6 than it is to 5. So we can estimate it. So I would say maybe like 5.9 or something like that. And then again here, it's going to be closer to that than it is to this. So it's between 8 and 9. So I'd say these are just estimates, right? Just asking to estimate down here, we're asking them. So it would be 5.9 and maybe 8.1, right? Something like that. I wrote these just as separate numbers and not as a ordered pair. If you wrote them as ordered pairs, you'd have this or this. So those would be our estimates. So approximately equal. That's supposed to be my little squiggly guy. Okay, now we're going to estimate the zeros from a graph. So from a graph, you can tell it's somewhere between 5 and -6, and now we can actually tell that it's closer to -6 visually. So, and between -2 and -3, but it's closer to -2. So I might say, oh, that's -2.2, comma 0, and -5.8, comma 0, because I know it's between 5 and 6, closer to 6. That's just me estimating it. Okay, so let's practice. Here we go. We're going to find the x-intercepts. So remember, the x-intercepts happen when y equals 0. So I just see a y equals 0 there, see a y equals there, equals 0 there. So what are my x-intercepts? 2, 0, and 7, 0. Yes, indeed, it is really that simple. So here, I'm looking, negative, negative. See how they're all negative? never, and this is my vertex. I can tell it's my vertex because of that symmetry, that -6, -6, 9, 9, -9, -9. So I know that it never hits. It goes up, then it comes back down, but it never crosses the x-axis. So there's no solution there. And then this one right here. Here's my vertex, and y is also 0 on my vertex. That means it just hit the x-axis and went back up. So there's just one solution, 1, 0, 1 root, 1 x-intercept. And that's it. So what are the x-intercepts here? Well, it never touches it again, so that's just no x-intercepts. Okay. Now it says to estimate the zeros. So I know it's between 2 and 3. 2.2-ish is one of them, and 5.8-ish looks like the other one. It's okay if you're a little bit off. After all, we're estimating. Here it looks like maybe -0.2 and 2.1, something like that. And those are my estimates. So that is how we estimate based on a graph and how we find our zeros from tables. Good luck with that. M² signing out.